NASA just put a smartphone into deep space. Astronauts captured mission images using a consumer device. Not a prototype camera, not custom aerospace hardware. An iPhone 17 Pro Max, flying aboard Artemis II. This isn't a gimmick, this is validation at scale. Extreme radiation, zero gravity, brutal temperature swings. Conditions that destroy most electronics within minutes. Yet this device captured usable, high-quality imagery. The camera system uses advanced computational photography pipelines. Multiple sensors fuse data into a single high-dynamic frame. Eye-driven image processing enhances clarity in unpredictable lighting. Even in space, algorithms adapt faster than human operators. Traditional space cameras are bulky, specialized, extremely expensive. They require calibration, training, and mission-specific configurations. Smartphones reduce complexity while increasing operational flexibility. Point, shoot, process, transmit, all within one device. But here's where it gets serious. Why would NASA trust a consumer-grade device in orbit? Because modern smartphones are no longer consumer tools. They are compact, AI-powered imaging supercomputers. The iPhone's sensor stack captures massive data per frame. Neural engines process billions of operations per second onboard. Real-time HDR balances shadows and highlights instantly. No external workstation required for critical image correction. Transmission matters just as much as capture. Images can be compressed, encoded, and sent efficiently. Bandwidth constraints in space demand intelligent data handling. This device meets those constraints without specialized infrastructure. Now think bigger. If a smartphone works in space, what else changes? Field journalism, filmmaking, remote research, all disrupted. High-end cameras face a serious long-term threat. For creators, this lowers the barrier to cinematic quality. For engineers, this proves reliability under extreme stress. For NASA, this reduces payload weight and mission costs. For tech companies, this is a global proof point. But there are still limits. Radiation shielding is likely added for mission safety. Thermal control systems may stabilize internal temperatures. This isn't entirely stock, but it's incredibly close. And that's the real breakthrough. We are watching consumer tech approach aerospace-grade performance. The gap between everyday devices and elite hardware is shrinking. Faster than most industries are prepared to handle. This is not just about photos in space. This is about the future of imaging technology. Hardware, and software converging into one system. Small enough to fit in your pocket. The next wave isn't coming. It's already here, orbiting above us.